example 13, we want to differentiate these functions. So we want to take the derivative of the natural log of 2x with respect to x. So remember, when we're taking the derivative of the natural log of some function, we'll call it u, with respect to x, the rule is you take the derivative of u over u. That will be what the derivative will be equal to. For this problem, we want to identify u. So u is 2x. So the rule says take u prime and divide it by u, which would be 2 over 2x, which would end up being 1 over x. So hopefully you can see part A clearly. Let's look at part C. If you notice, this time we're taking the derivative of x times the natural log of x with respect to x. So this time, this is going to be the rule, the initial rule is going to be the product rule, because there's two functions being multiplied together and you're taking the derivative of that. So that rule is the first times the derivative of the second plus the second times the derivative of the first, where x is the first function, ln x is the second function. So the rule would be x times the derivative of the natural log of x. So the derivative of natural log of x, if you used this guy here, u prime over u is x, the derivative of x is 1, and u is x, so that would be 1 over x, plus g of x, which is the natural log of x, times the derivative of x, which is 1. So now we just simplify this a little bit. 1 times 1 over x is 1, and then the natural log of x times x is x times the natural log of x. All right, let's look at part D. Part D, again, we're going to do the chain rule. This is going to be a power function with the natural log being plugged into that power function. So we're going to do the power rule to start. So you're going to do 3 times the natural log of x squared, because you would do 1 minus there. And then you have to take the derivative of the inside function. And the derivative of the natural log of x is 1 over x. So this would end up being 3 over x times the natural log of x squared. Let's look at 14. Okay, 14, in order to differentiate this, the logarithm of the square root of x plus 1, we need to go back and review all of these log properties. So you've got the product property, the quotient property, the power property, and change of base. These all refer to logarithms, whether they're natural or just base 10 log. So if you have the natural log of a times b, you can rewrite that as the sum of the natural log of a plus the natural log of b. That's known as the product rule. Next, we have the quotient rule. If you have the natural log of a divided by b, you can write that as a difference, the natural log of a minus the natural log of b. Next, we have the power property. If you have the natural log of a to some power, we'll say x, you can write that as x times the natural log of a. And then finally, we have change of base. So if you have log base a of b, you can rewrite that as log base b over log base a, which is the same thing as the natural log of b over the natural log of a. This should all be reviewed from college algebra. If not, if you don't remember this, definitely write this down. Maybe pause the video, write it down so you have it, because it's going to be crucially important when we're taking the derivative of these functions. So first of all, let's rewrite f of x as the natural log of x plus 1 to the 1/2 power. Okay? So hopefully you can see how we're taking radical, writing that as an exponent. Next, I'm still not going to take the derivative. The f of x, now I'm going to use the power property. where I'm going to take this and put it out in front of the log. So the natural log, or 1/2 the natural log of x plus 1. Now there's nothing else that I can do that involves these properties to expand this. Now I'm going to take the derivative. And this is kind of the process that you'll do every time you have a natural log function. You want to expand it using these properties and then take the derivative. So this is going to be 1/2. And then remember the rule is u prime over u, where u prime would be this, the derivative of x plus 1, which would be 1, all over u, which is x plus 1. That would be our answer. I can rewrite this as 1 over 2 times x plus 1. This would be the derivative of f of x.